Hello anyone and welcome back into this new video. Today I'm going to continue working on the CPU which I'm making on my Basys 3 FPGA, which is this little thing here. So for today I was writing into my log that I want to implement a detailed overview, let's say detailed diagram of the stages of the CPU, and I also want to start let's try to implement the instruction fetch stage, and that's it for now. I'm trying to get this logbook look better and feel better, because I don't really like right now these sections. So for today I changed, and now I'm writing like the plan for today and what I want to work on next. So yeah, so for today actually let me open the project and the integrated copilot, agent. So I want to start by drawing the different stages of the CPU, and I'm gonna do it here on the on draw.io. So let's start actually. Instruction fetch. Instruction decode. Execution stage. Is it called I know there is a write back in here, which is the last one, and then we have the I don't remember. So 5-stage CPU diagram. Yes, MIPS. No, just want to see MIPS architecture, which is the architecture which I am targeting on as the first one, which I'm then going to build on as it gets more complicated. So I don't really not even okay, this is what I was searching for. Yeah, memory access. Sure. So these are the different stages which for now my architecture is going to feature. Okay. So we start with a program counter. This is probably the most important register in the architecture. So it comes inside this little register in here. Okay. Then this program counter should take the instruction from the instruction memory. Should fetch the instruction from the instruction memory. So let me actually do something in here. Okay, it's here. Great. Yes. Okay. Okay. So, thanks to the instruction, thanks to the program counter, the instruction is then fetched from the instruction memory. So, let's take an arrow. Let's make the arrow like this. Okay. Yes. So I need more space than this, to be honest. Can I change the canvas size? Page setup. No, I don't want a US letter. Just start with an A4. Grid size, make it smaller. Way smaller, like 5. Okay. It's still very small. Let's go. I need 0. Okay. Yes, this is huge. Okay. It's huge. But, okay, no, too much. Too much. Hate you. Still huge, but never mind. So, let's move a bit things around to have a bit more space. Okay. Maybe even more. Okay, I think we are there. Yes. Okay, great. So, Here, let's actually move it a bit here. We're gonna have the pipeline registers, which I'm going to do like this and here, and there is gonna be 4 of them in each stage. Yes. Okay. I don't remember if we also need to have one there. 1, 2, 3, 4. No, we don't. Okay. Yes. Okay, so actually let's reuse this. No, actually again not. Okay, this is the let's try to keep some names here, because why not? PC. Oh my gosh. Let's make it smaller. Yes, here. So this is the program counter signal. Here we are gonna have the I don't know how to call it. It's like the row. Oh my gosh. Just press maybe. Oh my gosh. Why is it so big? Row instruction, I don't know how to put it right now. Okay. Here we're gonna have the instruction register. So I'm gonna call it IR. Oh my gosh. I'm also gonna give it a different color, like I don't know. Like, yes, this, which is like something between a pink and a orange. So we basically have the instruction fetch. The instruction is fetched thanks to the program counter in the next clock cycle. Oh yeah, of course everything in here has a clock signal, because otherwise everything would not be working. And then for sure we need another. Oh, sorry. Yeah, we need to go into electrical logic gates. Yes, this is what I want. And it's not here. MISC. There must be another somewhere. There is no way that there is no other. Sources. No. No, there must be somewhere. Okay, there's no other. No. No, no, no. Fuck, it's just... Am I stupid? The other is just a trapezoid. So I can just make it with... where is it? Can't find it. Here. Yikes. So let's rotate this. It's a bit too big, but whatever. Ah, yeah, we also need a dot. I don't know if it's already there. Maybe you can use this. Let's try to make it smaller. Yeah, something like that. No, fuck. Yes, here it is. And let's make it black. No, I don't want any... oh, sorry, let's make it white. Fuck. White. Yes. Is it wrong? No, it needs to be black. What am I doing? Oh my gosh. Remove the border. Yes. No. For now, let's put it here, because otherwise I will lose it for sure. And so I need to move everything a bit to the right, because I'm running out of space. Okay. Great. Now let's move this in here. No. What is happening? Not here. Great. And here we put the dot. No, the dot needs to be white. Fuck's sake. White. Yes, and no. I don't need any arrow in here. Oh my gosh. Okay. Yes. Okay, great. So here the program counter is going to be summed to the value 4. Why 4? Because every instruction is 32 bits. That's why it is called RISC-V 32. 4. Oh my gosh, the text is so big. What size is this? 7. Okay. And here we're going to save the next register, which is the next PC register. This text also need to be much smaller. No, fuck. But there is so much space between the words. Oh my gosh. Okay. Great. So we basically have the instruction fetch stage, I guess. Yes. Yeah, we do. At this point, we have the instruction. I mean, the instruction fetch stage. we need to access the register file. Register file. To select which value needs to be modified or used from the instruction that is going to be fetched. Okay, so yes, so we need some kind of decode block in here, which is going to extract these RS1, RS2 from the instruction, and also this sign extensions block, which it is used when an instruction from RISC-V need to be used as an immediate in the ALU. So let's make actually a decode block, which is something, I don't know, it needs to be much smaller than this. So this decode section takes the, no, I want it here, yes. Takes the decoded instruction. Oh, there, yeah, this is the next PC. Okay, let's remove this because I think it's useless. This takes the decoded, the encoded instruction, and I need more space. And once we have this, we also need the immediate block. The sign extension block. Yes. And what is going to happen is that also this need to make it a bit large. What is going to happen is from the decode block. No. My gosh. Okay. We are going to register source 1. I think also many other things actually, but maybe you can see that later. What the fuck are you doing? Yeah. Okay, so it's very ugly, to be honest. Maybe I can make it start from here. Fuck it. Yeah, let's put this in here and this here, and let's call this RS1. Yes. And also we need a RS2. Oh my gosh, it's fucking text. Okay. What is wrong with these fucking orders? Okay. This here is gonna be the immediate value, I guess. I guess so. Let's write immediate for now. Then yeah, of course the write back can write in here, but we're gonna see that later. And probably the decode is gonna have, oh no, I'm flying. Okay. Yes, we're live again. There was a connection problem, but we should be right back. So I was working on the sign extension block, and then here we can plug this arrow in the pipeline register, and also this from the register file. From the register file, we're just gonna have one operand, right? That one. Yes. No, I don't want to see this. I just want to see the image. So okay, yeah, we need to output two registers. I like that this is called immediate generator. Immediate sign extension. That's right. Then here we are going to output. Actually, let's do it from scratch. Yes, and yes, okay. So here we're gonna have RS1. This is actually the RS1, I mean, address, let's say. Okay. Wait. And then here we're going to have RS2. Okay, great. So we can save RS1, RS2. Here we have the immediate. I guess. By the way, maybe someone can ask, like, why am I not using just something like this and just using it as a base instruction and base architecture and just implement the same things that are implemented in here? The reason is that this is just the starting point, because I would then want to add extensions, different things like maybe a superscalar architecture or many other things, and I want a place where I can see my diagram and completely modify it. So I'm going to recreate everything from scratch. So I need to be able to have my diagram. And yeah, I guess yeah, here we have the immediate. I'm gonna call it INM. Okay. Great. Then what else? From here, we also going to have func3 and func7. Which need to be saved. Oh my gosh. What is the problem here? Oh my gosh. Yes, please. Okay. Okay. Finally. This is func3. Oh my gosh. Okay. And then here we have func7. Great. Yes. Oh, okay, these multiplexers in here, I'm gonna add them later. Did I just do a tiny mistake in here? Is it another or this is not exactly the same? Wait. Other symbol. Digital. Shows. Yeah, maybe it makes sense to be drawn like this. Let me see other drawings. Yeah, it's not exactly a trapezoid, but I mean, it's not that different either. We can just leave it that way. Yeah. Okay, so we can then move on to the ALU, I guess. Oh yeah, we also have the opcode coming here. And we should also propagate this Next PC. Yikes. Okay. Yeah, here we're also going to generate the opcode. Why do I need it here? I'm not sure I need it here actually, but okay. Let's move on to the next stage, which is the ALU stage. I mean the execution stage. So here we need another one of this, just much bigger. And this is the ALU. Oh, what the fuck? No. Okay, let's do this. Wait. No. What in the actual fuck? No, I don't want to run on the other way. Oh my gosh. Anyway, just gonna copy. I'm just gonna put the text in. Okay. Then here, wait, maybe I already have the. No, definitely not. Okay. This is pretty much useless. Can I just say it? There are not many things um, for digital circuits, I guess. never mind. So, what can go into the ALU? Well, the operands, I guess, from X. I'm trying to understand what is it doing in here. Yeah, it has for sure two operands, which can be multiple things. So let's actually move this a bit in here, and let's have other two small trapezoids, which are going to be multiplexers. Okay. Okay. And here we are going to have two. Actually, I can do like this. No. Are you joking? You're fucking joking. Okay. Okay. And then in here, yeah, the PC can go there, or the PC plus 4 actually. Yeah, that's true. Also, the normal PC needs to be saved. Maybe I can do this. Okay. Okay. So, I think I'm getting pretty sleepy for tonight. I probably, yeah, did half of the initial starting architecture that I'm going to build for actually starting to write any code. And that's it. I really like how it's looking like. It's cool. Let me save. And I think for today it's everything. I'm pretty happy, and the next time I'm gonna continue with the diagram, and then I'm going to start writing some actual code. Thanks you guys for following. See you next time.